All right, welcome back, geometry. We are going to now begin work on standard 7, which are proofs related to parallel lines. So let's get our standard scale in order here. And let's start with our key ideas. Okay, we want to be able to construct a 2-column proof for the following situations. When we have congruent angles using transitive property. Again, I understand that to start a new standard, you may not know what these are, and that's, of course, the goal is by the end you know what all of them are and are able to do those. Okay? So you want to be able to construct a 2-column proof for congruent angles using transitive property given parallel lines. And also, if you were have congruent triangles given parallel lines, and parallel lines using the transitive property and a converse, and parallel lines using congruent triangles and a converse. Okay, so you're considered to be at the beginning level if out of these 4, you can do one of those 2-column proofs. At the approaching level, if you can do 2-column proofs for 2 of those, you're proficient. If you can do a 2-column proof for 3 of those, and you're considered exemplary. If you can do a 2-column proof for all 4 of those. Okay, so again, I will remind you that on the back side of that is your self-reflection for you to kind of go through and keep track of where you're at in your development. Okay, so for in class 29 today, we have proofs involving parallel lines and the transitive property. All right, so let's review some of our critical information here. All right, so let's name one pair. Make this a little bit bigger for myself so I can see. Okay, so name one pair of each type of angle and fill in the blanks here. Okay, so corresponding angles postulate, remember, says that if lines are parallel, then corresponding angles are congruent. The same, right? So here we have 2 parallel lines and a transversal that cuts through it. So what's an example of a pair of corresponding angles? Would be angles 8 and 1. 8 and 1. Okay, 7 and 2, 6 and 3, 5 and 4 are all the corresponding angles. Okay, that's just one example. Alternate interior angles theorem says if lines are parallel, which we have here are 2 parallel lines, the alternate interior angles are congruent. Okay, this is review here. So alternate interior angles would be, for example, 5 and 2. Alternate interior, because it's across the transversal, or 8 and 3. Okay, next we have alternate exterior angles. Says if lines are parallel, the alternate exterior angles are congruent. Okay, so again, my parallel lines are here with the transversal that cuts through. So 7 and 4, for example, are alternate exterior, as well as 6 and 1. Okay. And the consecutive, that's the one that's different. Okay, consecutive interior angles says if lines are parallel, consecutive interior angles are supplementary, which remember means totals how many degrees? 180 degrees. Okay, So consecutive angles would be, for example, angles 5 and 3, as well as angles 8 and 2. Okay, so there's more than one example that could be given here. We just put one example down. Okay, next we have some important vocabulary, and that is dealing with the transitive property, which you remember from our standard scale we used transitive property. Okay, it says if two angles or segments are congruent to a third. Okay, if two angles or segments are congruent to a third, then they are also congruent to each other. Okay, if two angles or segments are congruent to a third, then they are also congruent to each other. So for example, if angle 1 is congruent to angle 5, and angle 5 is congruent to angle 3, then we know angle 1 is congruent to angle 3. Okay, likewise for segments, if segment AB is congruent to WZ, and segment CD is congruent to segment WZ, then we can say segment AB is congruent to segment CD. Okay, transitive property. So let's apply here. Okay, use the postulates and theorems above, as well as the transitive property and other previous knowledge to complete each of the following proofs. Use the same diagram for both proofs below. Okay, so the picture's the same, but it's there for you twice. Okay, so we're given line M is parallel to N. So if you want to mark that, you could mark that. Okay, we're given angle 2 is congruent to angle 1, and we're asked to prove angle 3 is congruent to angle 1. So as usual, we're going to start with what's given, which is line M is parallel to line N. And the reason is given. Okay. And since we're given that, we also know that angle 2 is congruent to angle 3, and that is due to alternate interior angles theorem. Okay, alternate interior angles theorem. See that? Parallel lines, so 2 and 3 are parallel. Okay, then we can say angle 2 is congruent to angle 1 because they gave that to us. And these could be in separate order. You could reverse those. I just tend to, if I know that two lines are parallel, if I can find something from that, I put that right away. Okay. And because of the transitive property, okay, we just said angle 2 is congruent to angle 3, and angle 2 is congruent to angle 1. Therefore, angle 3 is congruent to angle 1, which is what we're asked to prove. Okay. Next, M is parallel to N. Okay, so we're trying to prove 4 and 6 this time. M is parallel to line M, and that's given. Okay, and we're also going to pay attention to the fact that we're given 4 and 5, so we want to use something else with, rather than 2 and 3. We used 2 and 3 last time because we needed 2 and 3 based on that, right? So here, since we're given 4 and 5 also, let's see if we can use one of those. Based on the transversal here, with my parallel lines of M and N, I can say angle 5 is congruent to angle 6, and that's alternate exterior angle theorem. Okay, and we are given angle 4 is congruent to angle 5. Okay, so between those two, again, I can say angle 4 is congruent to angle 6 because of the transitive property. Okay, that's all there is to those. Okay, let's do a few more for practice. Flip the page. Okay, more proofs. You're so surprised, right? Okay, use the postulate and theorems above as well as transitive property and other previous knowledge to complete each of the following proofs. Use the same diagram for both. Okay, again, it's given to you. So M is parallel to N. That's given. Okay, we're going to be trying to show 1 and 7 are congruent. Okay, so anything I can use given that M and N are parallel using angles 1 or 7. Well, if you look here, I can use angle 1 and 2 are congruent because they are corresponding angles. So the corresponding angles theorem. Okay, next I am given that line J is parallel to line K. So K, J, and K are parallel. I'm putting 2 marks there to show the difference. They're different than M and N, right? Okay, so anything there that I can use using 1 or 7. I just used 1 and 2, so can I use 1 or 2 with these that also uses 7? And I see here I've got 2 and 7 because here's my transversal. Okay, so because of line J and K being parallel, I can say angle 2 is congruent to angle 7. And that is the alternate exterior angles theorem. Okay, now if I look at the 2 congruent angles I have, I can then say angle 1 is congruent to angle 7 by the transitive property. Okay, and at any point, again, if you feel like you're okay to give it a try, pause the video so you can give it a try on your own. And then hit play so you can check it. You gotta make sure you check it. Okay, next one's going to be very similar, where we're going to prove angle 2 is congruent to angle 6 here. Okay, so we're going to start with line M being parallel to line N. Okay, so anything with M and N, where I can use 2 or 6 here. I can use angle 1 and 2, because I'm trying to prove 2 and 6, right? So I can use 1 and 2 are corresponding. So I'm going to write that was given. So angle 2 is congruent to angle 1, the corresponding angles theorem. Okay, then I'm given line J is parallel to line K. Okay, and if I look at that, again, I've got 2 and 6 here, and I use 2, so I want to see if I can use, since I use 2 and 1 here, I want to see if I can use 1 and 6, which I can, because they're alternate exterior angles. That one's given. So I can say angle 1 is congruent to angle 6, because they are alternate exterior angles. Theorem. Okay, And now because of those, I can say angle 2 is congruent to angle 6 by the transitive property. See how you can use the parallel lines and look at what you're trying to prove to identify one of the angles that you can use that for. Okay, and maybe you're going to try one sometime, and it's not going to lead you to anywhere. You can try something else. Okay, try something else. 2 more, so let's go down and look here at number 5. Okay, we're given segment CD is parallel to BE. CD is parallel to BE, so these two are parallel. Okay, so again, we're trying to prove angle 2 and 3, so this is kind of like a transversal that cuts through it. Okay, so we can say angle 1, that's kind of hard to see, and then there's angle 1 is congruent to angle 2 by alternate interior angles. Theorem. Okay, next I'm given angle 1 is congruent to angle 3. Again, it was given, which means I can now say angle 2 is congruent to angle 3 because of my transitive property. Hopefully you're feeling like you're getting a little better grasp on it. Pause it if you haven't yet. Pause it and see if you can do the next one on your own. Okay, give it a try. Never know until you try it. Okay, otherwise you'll have an opportunity on homework, but this is a good chance for you to try it and check it before you go do your homework. Alright, next one, BC is parallel to AE. So parallel here to here. Okay, and that is given. Okay, and again, we're trying to prove angle 4 is congruent to angle 6. And if you look ahead a little bit, we've got angle 6 congruent to angle 1. So in our parallel, we've got a transversal here, right? Kind of look at it as cutting through if you want. Okay, and I can see using angle 1 and 4 that they are congruent because of alternate interior angles. Okay, and then we're given angle 6 is congruent to angle 1. And based on those two, I can conclude that angle 4 is congruent to angle 6 by the transitive property. Okay, probably should be putting a transitive property of congruent. Oh, they just have transitive properties, so we can leave it more okay. Alright, so that concludes in class 29 for today. Let's double check here. Yep, that's in class 30, so that finishes up in class 29 today. So you should now be able to go and complete homework 29.